Nick Coghlan, is a CPython core developer and a director of the Python Software Foundation, and his talk today is called Here Be Dragons, Some Elegant and Ugly Hacks in CPython. Welcome him.
Afternoon all, thanks for coming along. So there's the title. But here's the question. Why isn't all code beautiful? We actually know how to write good software, but most of the time we don't. And so it's like, why are there hacks in CPython? Popular, been worked on for a long time, has hacks in it. But not only why are there hacks, why do I think it's worth talking about them? Well, the thing is, there's a lot of stuff out there that teaches people how to write code well. We don't always listen, but the material's out there. And you'll find a bunch of it this weekend as well. But the thing is, learning to write code well is only part of the story. And exploring some of the nooks and crannies and dark corners of CPython, I think, can help illuminate some of those strange and harder to articulate parts that go into software engineering design. And so one of those that I'm going to start with is this idea of do the simplest thing that could possibly work. One of the big things we have to learn is when writing code is the wrong answer. There's lots and lots of reasons to write code, and just for the fun of it is one of the reasons. But when you are writing code to solve a problem, code is actually the enemy. You want as little of it in your solution as you possibly can. And so here's a recent one that came up in CPython core development, where it's about customizing syntax errors. And which one? There we go. So Python 3. One of the more controversial things we did was, well, one of them, yeah. We'll get to the example in a minute. So syntax errors. This is completely illegal. Syntax error, invalid syntax. I think everyone would agree that made no sense. What about this? Anyone want to predict what this will do? What? So according to the parser, that's perfectly fine. So, but the parser's not very bright. It just says, I don't understand, that's invalid, that's a bit user-unfriendly, particularly when people are migrating from Python 2. And we got lots and lots of people complaining about this. So we thought, can we do something about it? So this is one of my devel copies. Hang on, can I get that closer to the top of the screen? Gimme. There we go. Yay! Computers, aren't they wonderful? So, can we do better? So, this is still a bit cryptic, but this you can at least feed into Google, and by the time 3.4.2 gets released, I'll try and have an answer on Stack Overflow that explains what the hell this means. What the what will automatically Google tracebacks for you. And so anyway, so yeah. So the thing is, so the parser's really not very bright. How do we get to a point where we can actually emit a better error message like that? And so I'm going to switch back here. And my first answer, I said, let's change the grammar so that we let that get through to the later stage of the code generation pipeline. Because the parser consumes a grammar file that explains this is what legal Python looks like. And it doesn't actually enforce all the rules. We deliberately keep the language grammar for Python very, very simple. So it's basically pretty easy to write static analyzers for it. Static analyzers and parsers. And so it means that there is stuff that will make it through the parser into the rest of the code generation machinery that Python doesn't actually let you execute. And so things like the fact that break and continue have to appear inside a loop, return has to appear inside a function. The grammar doesn't actually enforce those rules. We do those during code generation. But the thing is that during code generation, we have a lot more information. And we have a much better idea of what the programmer was trying to do. And so we can spit out much better error messages. Whereas in the parser, we're kind of stuck, where it's like, it didn't pass, I have no idea, invalid syntax. And so to generate this custom error message, a while ago, just to prove to myself that it could be done and was actually compatible with Python's grammar, is I actually wrote an experimental patch that added implicit calls. So if you had a statement that was just a function and some arguments, it would go, instead of going invalid syntax, it would go, OK, I'm going to assume you meant to call that, and take the parentheses as implied. This creates all sorts of interesting ambiguities for a readability point of view, but technically it works. And so anyway, I had that code sitting around. And so when it came to do this thing of improving that error message, I'm like going, well, I've got that code sitting around. I know how to get the prints and the execs into the rest of the grammar, into the rest of the code generation machinery. So that's what I decided to do. And I actually created a patch that generated the message by getting it all the way through into the thing. Guido didn't like that one. And he actually had good reasons for not liking it, which is changing the grammar is a big deal. Every time we change the grammar, we risk breaking a whole lot of stuff, like the entire language. What would be wrong with that? And so anyway, so yeah, it was like, Guido basically went, we're not going to change the grammar just to improve a couple of error messages. Can you try and come up with a, and then he actually suggested, can we do something in the syntax error constructor? So in the constructor of the exception itself. And so as it turns out, yes, we can. Because the syntax error constructor, when it's generated from the parser, can actually see what code the parser failed on. And so what we actually have in the Python 3.4.2, which isn't released yet, but it actually has this check in the constructor for syntax errors. And so if it says, we've been given the text, and the text is actually Unicode, scan it to try and figure out if it looks like a print or exec statement that doesn't have any parentheses on it. And if so, emit that custom message. And this is one of those cases where you're like going, from an absolute software engineering point of view, this is a horrible, horrible hack. But from a user experience point of view, instead of getting a generic invalid syntax, users now get something that is at least specific to the problem they have, which is almost certainly that they're trying to follow a Python 2 example in Python 3, or they've migrated a script from Python 2 to Python 3 without changing the print statements. And so this then becomes something that is actually worth doing. But then it becomes a question of, well, how do we make sure that somebody coming along later understands why it's there? And so in this part of the code, you can see that I've actually referenced the issue where we decided to do this. So that'll get somebody back to the thing of, here's the full history of what the decision was, what options we considered, what we're actually trying to do. What you can't see here, because it's way too big to fit on the slides, is that that report missing parentheses function actually has a gigantic block comment above it explaining why the hack's there, what the heuristics are, where it doesn't actually work. Because there's a bunch of things in Python 2 that actually look, in the Python 2 print statement, that look like legal syntax in Python 3, but do something completely different. And so this becomes one of those cases where it's like, from a programming purist point of view, you'd say, no, never do this. But from a user experience design point of view for the language, you're going, yeah, no, this is worth it. Like, producing that better error message that will at least get people more easily onto the path of figuring out what's wrong is worth the cost of having this additional little hack to maintain. And so that's one of the reasons why we have ugly code in our things. We go, this particular thing is worth it even though there's no particularly nice way of doing it. But another reason why we have hacks in our code is this idea of an 80% solution. Some problems are just really, 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 really hard to solve properly. And so when you seem to be confronting one of those, it's worth taking a step back and asking yourself really seriously, do we actually need to solve the hard problem? Is there some subset of the problem that we can solve, and that will actually be good enough for what we need right now, and hopefully still leave us with the way of getting to a complete solution later if we need it? And this is often really worth doing because what you may find out is that either A, the hard problem didn't actually need solving and you actually never find the need to go to the full solution, or by the time you do need the full solution, somebody else may have solved it first. So here's an example. And let's nice secret here. But really, I can type this fast. So, decorators. Python, added in Python 2.4, really quite popular with a lot of people. And the end result was this. Well, that's not good. Everything decorated with my decorator is called wrapper. I'm sure IDEs will love this. This is a wonderful thing, although not so much. So for Python 2.5, the subsequent release, we added this wonderful thing called functools.wraps. And basically, yes, it helps to import the module you're going to call. And so, functools.wraps, wonderful. Actually gets the name right. So then the question becomes, how does functools.wraps actually work? So, well, if we grab the inspect module, what's it doing? Going, oh, well, that's wrapped a bit because my text is really big. But basically, the big line there is that, oh, it just calls partial on this other function in functools. OK, let's have a look at what that one does. So we've scrolled off the top a bit there, but you can still see the interesting parts, which is it's looping through and assigning a bunch of attributes, ignoring the ones that aren't there. And then it's looping through and updating a thing, and then it sets this done to wrapped thing to say, hey, I'm a wrapper. And yes, it used to do that wrong, hence the bug reference. But people thought I was being clever. It's like, no, it was just broken. So basically, what we have is we have a function that's just basically looping through a bunch of dunder attributes and updating the attribute dictionary. And that's really quite a brute force hack. It took about an afternoon to write it. It was one of the reasons there were bugs in it. But really, that's a very, very simple solution. And you're like going, so wait, we just define a new function that's the wrapper, and then we copy the dunder attributes from another function over the top. It's like, that's really, really ugly. But it's also really, really simple. And I wrote it back in 2006. But more recently, Graham Dumpleton has gone through and figured out how to do this properly and actually do a nice proxy object that you can slot in transparently and almost completely hide the fact that you've actually wrapped the underlying function. And that was really, really important for Graham's use case because he's injecting stuff into existing applications. Whereas for our use case, we just wanted people to be able to write decorators properly. And so what that meant was we got an extra 7 years before the problem needed to be solved properly. And so 7 years out of a really, really simple solution that solves a subset of the problem, that's a pretty good deal. So that that basically became a matter of something that didn't take a lot of engineering effort, basically deals with the subset of the problem that applies to writing function decorators. And then Graham's wrapped module now exists, and you can use it to solve the much harder problem of transparently replacing any callable with a wrapper that does some additional things around it. And so yeah, so I'll basically take that as a win. That was a hack that worked. That bought us 7 years and dealt with the subset of the problem that we actually really cared about. And then Graham came along and solved the additional 20%, which is much, much harder to solve, but is also a more comprehensive solution. So again, another example of where hacks can be useful. So another time where it can be useful to do things that maybe make us cringe a bit as developers is that we can basically look at the thing of, can we do something to make this easier for people just getting started? And so this was interesting helping out at the Software Carpentry Bootcamp this week, was one of the things that people get stuck in with command line applications is if a lot of the time if you end up in a command line application, you're like going, how do I get out? Man pages on Linux. There's nothing there to say Q to quit. There's nothing there to say Q to quit. And so this is something that Pico and Nano are still better at this than most other Linux command line text editors. Because in Pico and Nano, they actually have the bar at the bottom that says Control-X to quit. So this thing of can you give users some kind of affordance to say, please let me out? And so in Python, unfortunately, I don't have a demo of the old state because we fixed this one a really long time ago. Or at least we didn't fix it. We made it less bad. And so in Python, and so this applies in current versions of Python 2 as well. If you're at the REPL and you try to quit or you try to exit, it'll actually print this little message saying, here's how to actually quit, here's how to actually exit. For a very long time, this actually just printed the wrapper of a function. And you're just like going, what? And so we thought, OK, can we make this better? So again, this is an interesting way to say, well, how does this actually work? And also, if you type quit and exit into your normal Python program, you'll actually get the name error because they won't be there. And so exit is this thing from the site module. So we'll import the site module. And look at what that method is doing. And so in the function, it actually has this quitter definition. And so the quitter, you can see in the wrapper, it's actually printing out, here is how to actually call this thing. Or you can use the Control-C or Control-D, Control-D or Control-Z, depending on what platform you're on. And so that's kind of useful. But couldn't we have made it even easier? Why couldn't we just say, do what I mean? That sounds like a fine plan, right? Doesn't cause any problems. Wait, we haven't actually instantiated that yet. Let's try that. Now let's display the globals. How well's this going to go? Oh, oops. So that's why we don't do it automatically, because that would be a really bad idea. There's a limit to our hackery. OK, so that's it for that one. Now, we move on to one. Hang on. Let's get back to our presentation here. Now, this one. Python has some really, really cool metaprogramming capabilities. You can do dynamic type creation. You can use meta classes. You can do AST-based metaprogramming. I'm here to say don't. Don't use them if you can absolutely possibly avoid it. If you're asking the question, do I need to use a meta class, the answer is no. If you need it, it will be because you've exhausted all the other possibilities and you are basically, you've stopped asking that question, you're going, yes, I need a meta class. And there's a reason for this. These things are really, really powerful. They're also really, really hard to understand. As soon as you use them, you have created a maintainability problem for yourself. Because anyone who has to come along and make changes to that code later has this wall in front of them which says, step 1, learn how meta classes work. That's a maintainability problem for you. Because it means that you have now taken that section of your code, and the only people who can maintain it now are people who understand meta classes. That's a much smaller subset than the whole pool of Python programmers. Now, sometimes it's absolutely worth doing because it makes your own APIs much, much easier to use. And we have custom meta classes in the standard library for the same reason. But they really are power tools. They need to be used as an absolute last resort when the simpler options don't cover it. And so the question is, do you need meta classes to implement a type factory? Or do you need dynamic type creation to implement a type factory? And so people may have heard the complaint, I really, really love using nametuple, but I hate the way it's implemented. Why would people say something like that? Because nametuple really is cool. So if we go here, oop, that's not going to work. There we go. So let's drop. Let's have a look at named tuple. So if people haven't seen what named tuple does, it's actually this really neat thing that makes it easy to define custom tuples that have named attributes and nice representations, but don't use any more memory than an ordinary tuple. That's actually really cool. And one of the big reasons for using named tuples is when you have thousands and thousands and thousands of objects, you want to be able to use names to access the individual fields rather than magic numbers, but you can't afford the memory hit of a full class instance. And then named tuple is a really, really nice memory optimization. And also just really nice to use. And I do the thing with using it in a class just because it just looks a lot more like a normal class at that point. But anyway, so why do people complain about the way it gets implemented? This could be a bit tricky. Let's scroll up a bit. Well, let's look at that comment there. Execute the template string in a temporary namespace and support tracing utilities by setting a value for frame.f globals. So yeah, collections.nametuple. So template string. Let's go a bit further up. Fill in the class template. Class template.format. Well, that sounds interesting. Let's have a look at that. Well, there we go. That's certainly one way to do dynamic type creation. This is awesome. And the reason it's awesome is that done-to-new definition right there. So to actually do this another way, you would have to figure out how to do this with dynamic type creation, which most people won't understand. And you'd also have to figure out how to write that done-to-new method without using string formatting. And that's actually really hard. Greg Smith, one of the other CPython core developers, says he's actually done this and figured out how to write nametuple without using string formatting. You have to do AST metaprogramming to actually create your done-to-new implementation. So what we basically have is we have a current implementation of collections.nametuple, where to understand it, you need to know how string templating works, and you need to know how exec works. There's a few other little odds and ends that you need to understand the details, but those two are the big, big items that you need to know string templating, you need to know exec. Most programmers are going to know string templating. A lot are going to know exec as well. So really, that's pretty easy to understand. It's pretty easy to maintain. It's got a few odds hacks here and there to make pickle work and introspection and various other things. But honestly, for what it does, that's actually an incredibly simple and easy to understand implementation. And so it becomes one of those things that it does come up on Python dev because people hate this implementation with a passion. They hate the idea of formatting a string and then execing it to do dynamic type creation. But really, we have all this type creation machinery in the language. And that's actually one of the easiest ways and easiest to understand ways of getting access to it. So you don't have to do it this way. And the dynamic type creation and ASD metaprogramming and all that sort of stuff is actually really powerful and really useful at times. But it is a big barrier to maintainability. And something like this may actually be a better answer in some cases. So that includes question time, doesn't it? OK. So we only got a little bit of time for questions. So basically, but that said, don't take this as a recommendation to just ship anything. Technical debt is a real problem. That if when your project accumulates too many hacks, too many cut corners, too many odd design decisions, you just end up painting yourself into a corner where you can't change anything anymore. Good tests, good comments, good design, code review, these are even more important when taking shortcuts than they are when you're doing things the simple, obviously correct way. If you're not keeping your technical debt under control, you will end up with an unmaintainable mess. But at the same time, if you never ship a hack, then you're going to have some very, very unhappy users because you're not going to be able to give them the features they want in a timely fashion. So the way we balance those is we refactor ruthlessly. You have to recognize when you've hit the limits of a shortcut and take the time to pay down that technical debt, even if it means making your users hate you for years. You really need to do it sometimes, or you'll just end up not being able to do anything. So now on to some questions. Sorry. And if you could come down to the microphone.